Yeah, I want to show you how to do the one-way analysis of variance. Before we do that, let us see how the data should be prepared in the dataset file, which is an Excel file. Now, let's show that. This is the Excel file. You can see the data set. See, the first row of the Excel sheet contains the names of the different, do we call it entity or do we call it variables that we want to look at. And then we look at, the first one here is DESC. This DESC is very important. It must be there because it's the one that will describe the each of these figures, what they relate to. In this, we are assuming that there are 5 depots by this company or by this group. Where you can use that depot, could be town, it could be a location, but we decided to just call it depot 1, depot 2, depot 3, depot 4, depot 5, and it starts again depot 1, depot 2, depot 2 until the end. Now, in each of these depots, we have winery products. We have bakery products, we have shoe products, we have PVC products, we have tobacco products, we have cyber cafe, and then you have cab hire, you have tires, and you have juicer. And the figures that are below them are whatever, whether activity figures like sales or whatever, or shipments, the number of shipments. So what we want to do now is to do a one-way ANOVA to see how different these things are, the means of these things are, which is always what the ANOVA is all about. Now, let us now look at so that is the VSP. So now let's look at the VSP. Now we call up, we go to the menu, we select statistics, we look at analysis of variances ANOVA, and then we go to one-way ANOVA, we click one-way ANOVA. So the one-way ANOVA, we are waiting for the form. Waiting for the form, it will soon come out. The form has come out. Now, we see that we have a lot of this thing here. That's all the whole branches, or rather all the whole product lines are here displayed by the form. Now, we need not select all of them, but we can select only those ones that we want to analyze, and that is what we want to do now. Let us assume that we want to analyze the winery, the bakery, then tobacco, and let's say tires. Just these 4, and probably let's add the juicer. Then just these 4, and we click process. So that's it. So it has finished processing. You can see, first of all, the box plot for each of the levels that is trying to look at here. So once we click off the box plot, then it will show another one. This is the line graph. Another box plot. I think for the 4 or 5 that we choose, it will be showing the different graphs for each of them. Yeah, this is for the second one. This is the line graph for the second one. Yeah, this is for the third one. This is the line, the third one still. This is the line graph for the third one. Then, yeah, this is the box plots for the third one. Now, yeah, so I think that it has finished displaying this. So we now go to the figures to see the figures that are behind those plots. Now, these are the figures. These are the figures. The figures are here as computed by the VSP. You see the VSP logo. Now, these are the data set, the data used for the analysis. You can see this is what do you call it now? The descriptive statistics. Now, the descriptive statistics, yeah, the first thing here is the count. That's the number of items in the count. Even though it displays the descriptive statistics for all of them, without actually zeroing in on the one that we choose, but I think by the time it will go to the analysis, it will only center on all and those that we have chosen. Now you see the mean for each of them. Now see the standard deviation for each of them. The minimum value, 25%. That's the quartile range, and then this is the 50% half range, and then this is the 3/4 range, and then the maximum value for each of them is listed here. Yeah, so now let us now move further to see what other things that we have here. Other things that we have is 8 rows times 9 columns. Then the value one way ANOVA, the F statistics is 0.8596 and so on and so forth. While the P value is 0.0442, which is not significant. That means that actually that there is no significant difference between the means of these the groups that we studied or that we analyzed. And when you look at it, you find out that actually look at the means, 2.7, 2.9, 2.7, 30. You know, the differences are not much. When you look at them, the differences are not much. So that is what you say. You know, we are looking at the significance, how significant the differences is. There could be different, but they are not significant. Now let us look at the pre-estimation result, as well as regression results. You have the R square 0.079. Dependent variable, we use the tires as a dependent variable here, okay, which is the last thing that we chose there. And then the model is OLS, adjusted R square is minus 0.091. The F statistics, we have already seen that. And then the probability is 0. This. The log likelihood minus 178 this. Then Akaike Akaike criterion, then Bayesian criterion is this. What I just mentioned are some of the statistical values that also help in interpreting what we are analyzing here. The number of observations is 20. Degree of freedom is 16, and then lower type is this. Now, more of the results we have. This is where it's now narrowed down or zeroed down to the one that we choose. We have the constants at this, and then the winery, the bakery, the tobacco, and so on and so forth. Then the omnibus is 26 points. This Dublin Watson is this 1.2820. Then Jackie Berra this. Then probability of Jackie Berra is 6 points. I think that is. And then conditional number is then kurtosis and skew. They have it here too. Now, notes. The standard errors assume that the covariance matrix of the errors in is correctly specified. The condition number 2, the condition number is large. That 2 point. That's talking about this. The condition number is large. It's 2 point. This might indicate that there are strong multicollinearity or other numerical problems. Yeah. So, however, just note that this is just a figure we use just for the purpose of demonstrating this. It is not live figure. If it's live figure, maybe we have given a better interpretation to that. Then post hoc Toki HSD results. Then multi comparison of means. That's Toki HSD. Then group 1, group 2 mean different. Is this bakery to tobacco? Is this one, and then lower, and so on and so forth. Yeah. Then tobacco, you have bakery to tobacco, bakery to winery, and then tobacco to winery. You see, it just compares them and then does the post hoc analysis. And the result showing that say under reject, they say false. Say we should not reject that the null hypothesis stands. The null hypothesis stands. We should not reject the null hypothesis. That is that. And then eventually this is now telling us that results is saved to C value start ANOVA results.txt. So, and that's about this particular one. Now, if we want to confirm whether it is actually saved here, we just simply go to the file distribution, and then we look at we go to the C, the value start. Yeah, value start. We go to look at this C. Yeah, this is the value start folder. So we click it open and see. Now, what do we have here? Okay, when you look at this, okay, you can see that is the ANOVA results. ANOVA results. So we click it open. Aha, you can see it. So the same thing that was shown us is what is also here. And look at that post hoc Tukey HSD test showing us the same thing. So that is about the one-way ANOVA. Remember, to prepare the data the way it should be accepted. I show you the way it was prepared before it was accepted, and I also show you the fact that the data itself must have a particular column that is called DESC, must have a particular column that is called DESC that describes the entries there, and then all the other columns are the ones either the products or the variables or the locations or even the names of companies or entities that we want to compare the results that are under them. So that is how you prepare for one-way ANOVA. Thank you.